Ooh, I got this one.
Oh, good. Okay, no, we're up. We're up. We're alive. Okay.
Oh, we've got like to write. Do you have me? Is that how you want me to do it? You want me to like say like, oh, there's a question and I'll say a question? Do you want me to just put it up? Like a bunch of times and I'll like write it down here and then I'll be okay. Read it from over here, but I think it'll be right. Maybe. Like strawberries. This is a very mindful like. Anyone who like sitting next to us like phone stuff to myself, I could just take pretty much only like this one enough. It's pretty much yours.
Days ago, we did 250,000 channels.
Oh my god. Yeah, there's heaps of ones that I have to is what gets through everyone through that's everyone. Like no one watches like everyone watches YouTube watches AS ones, but most people Surely you just get a link to the list link to the playlist.
Right.
I would like putting every my experience.
Oh, yeah. Like sound.
Oh yeah.
Just like pop up. Oh,
It was
yeah.
like yeah. It was like sort of like in the corner.
Yeah.
All right. Maybe, no, hang on. Not yet. Maybe now? Can,
We have liftoff.
yeah, do we have we got sound and have we got, oh, why is there no, oh, that's not nice, Ben. I guess we have sound. So everyone can hear me online and see things. Today will be a better day. There will be no green screens, maybe. There might be other issues. Okay, good. Are we coming at an average? Are you looking at that or not? Okay.
Checks out.
All right. Well, welcome back. Thanks for turning up again, even though Monday was just special. It was really special. So today we're going to forget that Monday happened and we're going to start linked lists, which is so much fun. I love linked lists more than arrays, more than arrays. Yeah. So today, Tom's not here. Paula's doing the chat. You can ask questions. And then Ben is here for my mental health and well-being. He, as you can see, he just always says everything's going great. So that's what we need. Okay, so any questions, pop them in the chat. And other than that, we're going to be doing some while loops today. Do you know what? You will be very pleased to know it will be while loops today because linked lists like while loops a bit more. And it just looks a lot neater with a while loop than a for loop in a linked list. So we are going to go to while loops today. Okay, so let's, oh, why does it say that was the wrong title for it? Anyway. Okay, so today we're going to try, these are the wrong lecture notes. These are the wrong lecture notes. These are not, they're 22, they're the wrong lecture notes. Oh, I'm just going to lose my plot.
Where are the right ones?
They're also somewhere there. Well, they're on the website actually.
Let's double check the website.
Did you put them on the website?
Certainly hope so. I tried.
It can just go all perfectly, can it?
Where would be the fun of that? Yeah, no, the slides are on the website.
Yeah. I knew it.
Do you want me to grab?
I've just forgotten. There we go. Is it week 7?
Wednesday slides, yeah.
It is Wednesday. There we go.
That's right.
I thought that something was wrong. I was like, who knows what lecture we're up to? It's week 7. I can't believe that anyone knows anything. Okay, so here we go. Oh, someone's got a good question in the chat. I'll let Paula answer it for a second. Yeah, it's definitely not lecture 13. It's lecture 12. I'm not moving you along at the pace of light. Okay, so last time, disaster really. I mean, it was just lots of green screens and just that was it. But we did learn about malloc and free. So if you remember, malloc is a function that we use to allocate some memory. And we're going to need that because we're going to be starting to play with memory ourselves, not just let, just let the computer do its own thing. So we're actually going to play with memory ourselves, and that's where we need malloc. So malloc will create some memory on the heap for us, and it will return an address to that piece of memory that it has created so that we're able to access it and use it. And then when I've gotten some memory, it would be quite rude to keep making memory. So I have to free the memory that I've made, otherwise it persists and you will slow things down. So if you don't free the memory that you have allocated memory for, that you've used malloc for, you haven't freed it, that is what is called a memory leak. You might have heard that term before, and that's what slows down your computer a lot and eventually potentially crashes it. As well, it is also a bit of a security vulnerability as well, and you might learn more about it. C is a great language for security vulnerabilities because it's got, you play with memory so much that you're bound to do something wrong. Just inspiring confidence. You're bound to do something wrong when you play with memory. Don't worry, you will. It takes time, and even when you use C for 20 years, you still make mistakes. Okay, so today, linked lists. We're finally learning about the second data structure that you will be tested on. That's, arrays and linked lists. That's the whole point of this course, is that you come away knowing about these two data structures. So we're going to learn about what is a linked list today. We're going to learn how to insert into a linked list and how to traverse a linked list, and maybe even how to insert at the tail if we have time. But let's do it in a non-rushed pace and do it properly, so that, because it's an important concept. So once we start, let's actually get it all going. Okay, lecture code. So Paul, if you can post the link to the lecture code in the chat, that would be lovely. And let me talk to you about what is a linked list first. All right, so we've talked a little bit, if anyone was listening before, we've talked a little bit about how an array is allocated memory. And you say you need to give a size for that array, And so the memory is allocated at compile time. So if you say you want an array of size 1000 because you're taking a wild guess how many things you need, it will create for you an array of 1000 ints or whatever it is that you're using it for. And then if you use only 10 of that, well, there's a whole bunch of stuff that's gone to waste. So it's not really a very, efficient way to do it if you don't know how many items you're going to have specifically. Similarly, if you use all 1000 of them, you're going to have a hard time getting more memory because there's nothing else there anymore. So you're going to run out of space, and there is no easy way to add something at the end afterwards. So you are going to run into some issues, and that's part of the issue with using arrays, is that it's not an efficient use of memory, really. So there is something called a linked list. And the way a linked list works, okay, look at me, so prepared. Here we go. Is, let's say we have, almost so prepared. It'd be funny if the pen wasn't charged. Okay, so let's say you have this chunk of memory. And so, as I said before, an array is allocated. It's going to be a consecutive chunk of memory. So what that means is that you can access anything in an array with an index because you know where it starts. So as soon as you know where it starts, everything else is consecutive, one after another. And that's really useful because you can index things, and I can be like, okay, can you give me something at index 5 or index 6, and I can do that really simply. Now with a linked list, that is not the case. A linked list is something that is made up of nodes, okay? And each node can go wherever on Earth I want it. Well, not where I want it, where the computer puts it. And what I do is I link up those nodes by using addresses of those nodes. So what happens is you malloc some memory and you create a node, and you've got where it is, and then that node will know where the next node is, and that node will know where the next node is, and that will know where the next node is. So what happens is they're not consecutively stored in memory. You can't say, I want the third node of the linked list without starting from the first node and moving to the third node. You can't just access whichever node you want. You have to traverse the whole list. And that's because it's randomly stored in memory. Wherever there was a bit of memory, that's where it's going to put the node. So what that means is it allows you to dynamically create a node whenever you need it. So whenever you need a piece of memory, that's when you create it. And you just shove it into your list. And that means that it's a lot more efficient, obviously, as well. So if we were to have a look, okay, so what that means is each of these nodes, and I've promised that I would use the squares that are provided here, and then I started drawing again. I'm sorry, I am going to use squares because otherwise it's just hideous. So if you have a node, let's say we've got a node, I'm drawing it as a square. It might not be a square. Inside the node, that means you always have to have an address of where the next thing is. So I'm always going to have the address of the next node. So it's like a scavenger hunt, if you've ever been on one. You go to one place, you find, like the Amazing Race, that's what it is, yeah. You have to go to the place, you find where you have to go next, but you have to get to the end of that place, and you can't ever skip a place. So it's kind of like that. So you've got the address to the next node, but also, what's the point of having a node without actually having any data in there? So you also store some data in there. So you might have some data, and then you'll have an address of the next thing, and what it will do is it will go to the next node. And then the next node, again, has the same things. It has an address here, and it has some data that you're storing that you actually are using. So what makes a linked list is this idea that we always have a piece of memory that holds the address of the next node after it. So all you ever know inside that node is where the next node is. You don't know where the previous one is. You only know where the next one is. There are ways to have more complicated linked lists where you keep hold of the previous one, but we're not doing it here. We're only doing one-way movement. Okay, so how do you reckon we could do that? How do you reckon we can create this node? So one way to do it, I really hate that this mouse goes the opposite way to how I want it to go. is to have a struct. And inside this struct node, so we're creating our own structure for a node. We're calling it a node. You can call it whatever you want. Really, a node is just a term of what each nodule is called of a linked list, but it can be anything else. The only thing that will make it a linked list is having this bit here, which is what says that it's keeping a next here. So it's got a pointer to the next node, and it's of type struct node. So in this particular node, you're holding some data, which is this data here, and then you're holding an address to the next node. And that's the address to the next node. And then they link together by using that next node. So that means if you have many nodes together, you're going to have each one of these is going to have the address of the next one, the address of the next one, the address of the next one. So there is something missing in here. Is inside my memory, I have this beautiful thing here. You know, I have a linked list of nodes. And how do I know where the first node is? Because I'm not really able to maneuver or do anything without knowing where my first node starts. I need to know where the first thing is to be able to maneuver through it. And so you also have a pointer to the very first node that will tell you where this one starts. And usually this pointer is called the head. So, I mean, again, it doesn't have to be called the head. You can call it first node if you want, but the head is kind of just like the standard thing of what we named. The head of the list is that's pointing to the very first node. So all that will be stored inside the head is the address of that first node. And that will allow you to traverse through it. So each time you have the pointer to the first node, that means it will store the address. So you'll go to the first node, you can access whatever's inside that node, and then this node will have the address of the next one, and so on and so forth. So maybe now you're seeing you're going to be using a lot of those little stabby arrows that we did on Monday because you're going to be accessing a lot of pointers that are structs. Okay, and how do we know that we finished a list? Because right now it's just hanging out. There is, nothing much happening. There's an address of something. So to say that we've gotten to the end of the list, at the end we point the last node. Let's say this is my last node. It will point to null, which means that there is nothing coming after it. And that means that you are at the end of the list. And what that allows us to do is it allows us to traverse the list and know where that list has finished. So when we get to a null, we know that we have come to the end of the list and that's it. Okay, so should we do a little bit of code just to see it happen? And then I'll draw it as we do it as well so that you can see the magic happen. Magic, maybe. Okay, so let's have a look. So first of all, you've got to hash include the standard library because that will allow you to malloc some memory and free some memory. And each time you create a node, you're going to have to get some memory to create that node. So you need a piece of memory where that node will be because you're dynamically allocating it as you need it. Okay, so let's say, and you will get very familiar with this structure over here, this struct node, struggle town, there we go. So this struct node over here will become very, very familiar because okay, here we go. So inside it is going to be some data, which is perhaps, I don't know, right now it's an int, it could be a char, it could be a string, it could be anything. There could be more than one thing in the node, as long as it has the address of the next node. And then it has the address of the next node, which is of the same type. So the same type as struct node, which means that the next thing, the address of the next thing is also a node. So each time you're going to be building up this structure. Okay. Let's do one for creating a new node. How does that sound? So eerie and quiet in here. Okay, so let's think of what we have to do to create a node. I'm going to come up here and okay, I'm going to erase this and we're going to think of what we need to do to create a node. Okay, so I've kind of like mentioned it in using language, but what do we reckon if I wanted to create this node, so I wanted to get some memory for it, I will need to malloc some memory to create it, yeah? So as soon as I call this malloc, and should we do it inside main and then we'll move it into a function? Let's do it inside of main and we'll move it into a function. Okay. So creating nodes. So what do we need first of all? So the first thing we need is we need the address of that first node, and that's going to come out when we use the malloc. So how do we want to do it? We want to malloc some memory, and that will create a node for us. Okay, so the first thing we need is we need the head. So I'm going to say that I'm going to have a pointer called head, and it's going to be of type struct node. So it's going to have the same structure as that node that we defined. And the head is what will hold that first value in it, or the address of the first node. Okay, so now I want to actually create the node. So if we're creating the node ourselves, which is a nice thing to do, we want to malloc some memory for it. So let's say we're going to say the head is now equal to, we're going to malloc some memory for it, and we're going to use our size off. And what do you reckon the size off will be off? What do we need memory for if we're creating a node? You can put it in the chat. There we go. Then no one has to speak. Not quite an int, because remember, if it's a node, it also has to have an address to the next thing. So it has to be a node. I want memory for a node. No, not quite. Good guess though. The head will hold the address of my node. Yeah, okay, struct node. So I want to create a node. So I'm going to malloc some memory for a struct node, because that will allow me to create this structure over here. That goes the opposite way, sorry. Okay, so every time then I call malloc and I ask it to do size off, what it does is it creates this. So I've called malloc. I think I might have to write the code because there's not enough room here. So if the code is like this, I should really call it. So let's say I'm creating a pointer to this, so new node, and you can't see it. It must be, there it is. So I'm creating a new node and I'm calling malloc for it. And I'm mallocing enough memory for size off struct node again. And remember my node, so the struct for the node has inside it, it has an int data, and it also has a struct node next. And what that struct node next is, it's really the address to the next node. So whenever I malloc some memory, I get a pointer to the, so I get the address of that, and then what that malloc does whenever it's called is it creates the structure for me. So it creates that, and I've got size of struct node, so it will create for me that, and it will return the address of it. So let's say the address is 0xff0, completely made up, doesn't mean anything. So what that means is inside the new node is going to be the address to that node. Okay, so if we were to call some memory now, not call some memory, make some memory. Okay, so we're inside there, we've malloced some memory. Now what we want to do is we want to give it some data, let's say. So let's say, for example, and this is not dynamic, we're just hard coding it. Okay, so let's say we want our node to store the value 3. Okay, right now it's sitting inside the head, which is just a weird way to do it. I shouldn't have done that. But it's happening now for now. We'll change it in a second. Okay, so to access, remember this is of type struct node, which means it is a struct, and that means to access that pointer, we're now going to use our stabby arrow. So we access that, and we've got 2 points to it. So we've got 2 things in our node, 2 members in the struct, and one of them is data. That is where the values go. And the other things, and the second item is the address of the next node, which is your pointer next. So that means if I do head data, so I'm assigning to data, I can say that it's equal to 3. So I'm assigning some data to it. And then I want to put an address for my next one. So then into my next one. And where do you reckon, have I got another node? Have I got something to point it to? Or there's only one node, so what do you reckon should be the address that it's pointing to? Yeah. Did you just...
We got it in the chat.
Yeah. That's how I was like, is that why you're so excited? Yeah. Yeah. Okay. So no, because there's nothing there. I've got no other nodes. I've got nowhere else to go. It's a very short scavenger hunt, just one node. Okay. So that means that we've got one thing. We've got this beautiful one node, and we're not printing out anything, and we're pointing it to nothing. Okay. That's quite nice. Gosh. What do I do now? How do I do the next node? This really, if you're going to be creating many nodes, what do you think it's a good customer for? I think it's a good customer for a function. Don't you reckon? What do you reckon? And because you will be. You're going to create more than one node. You don't want to put it all in main. So why don't we do, oh, someone's asked why do we use the arrow instead of a dot? So the arrow is the same, well, not the same thing as a dot. The arrow is how we access a struct pointer, basically. It dereferences the pointer, and then it does the dot so that you don't have to use brackets and stars and go insane of where it's going. So that arrow is the same thing as doing this. So that's why we're using the arrow instead, because then we don't have to do the brackets and the star and the dot. We just have the arrow, and it does the same thing. It's saying dereference head, and then access the member data. Okay, very good. Okay, let's put it inside a function. Okay, so if a function is creating a new node, what do you think will be the output of that function? What do we reckon if we're creating a new node? What will be the output of it if we've just made magic and created a node? What do we reckon? Yeah. Okay, so our new node will be the output of the function because we've just created this lovely node, and that will be our output. And what do you think we need to create the node? So what are the 2 things that we used in our main to create the node? We need 2 things because there's 2 members in the struct. There's data and next. So what would we need to give this function to create the node? What do we reckon? So silent. It's not that bad. Linked lists are fun, I swear. Yeah, so we're going to give it those 2 members. So we want to give it some sort of int because it's an int data, and we want to give it an address, which is what it should point to. Okay, so what we're going to input it and is some data. So our int data, and also we're going to give it the struct node next. So we're going to give it the next address. So which are the two members of a node? Okay, great. Okay, so let's create this magical function, and you'll be using lots of these functions over and over again. Okay, so we're going to be returning a struct. We're going to be returning the new node, which means that we're returning a struct node. And if we are returning a struct node, what do you think? How can we return that node? What do you think we'll be returning? Will it be the whole structure of the node? Will it be the address of the node? Will it be, what will it be? What do you reckon? What do you reckon is a useful thing to return? Name of struct. It's a good guess. Not quite. Yeah, the address would be the most useful thing to return because we would need to know where it is located to link it into our list. So we need to know the address of it. And if we need to know the address of it, that means it's going to have a pointer. It's going to be a pointer because it's going to be an address. So we've got a struct node create node, and we're going to give it some data. And what we're also going to give it is we're going to give it the address of the next thing so that it can be created. Do you want me to call it address or next? What will be less confusing? Next, to match it up. Okay, I'll call it next. So then it's like exactly the same as the node. Okay, so what did we do? I'm not going to go back to it. I'm going to make you try and remember what we did. Let's try it again. Okay, so we need to create a new node. And what I'm going to do is I'm going to create a pointer to hold the address of this new node. So what I've said here is that I'm creating a pointer called new node, and it's of type struct node. So I've basically created an address to hold a node. So this is going to be what I want to return out of this function because this is what's going to hold the address of my new node that I've created. And then I'm going to grab some space for it. So I'm going to malloc, I'm going to size off, and I'm just going to not spell correctly, struct, no. So I'm going to malloc size off, and I'm going to do a struct node, which will give me exactly the size that I need to create a node. So it'll give me the space to have the data and the address inside the struct. So what this has done, line 47, is it's created the structure for me. It's created the struct and the space for it, and it's given me the address of where it has created it. So now I will assign some data to it. So I'm going to access my new node, and I'm going to access the data portion of it, and I'm going to assign, and this is where sometimes this gets confusing. So this is the input that I've given it, the parameter. So I'm going to assign that to it. And then I'm going to access the next member of it. And this is where I'm going to give it my next that's stored in here. Okay, and then what do you reckon I'm going to return out of this function? What holds the address of this node that I've created? What do we reckon? Yeah. Yeah. A few people in the chat. That's right. So new node is the item that holds what I've created. Okay, let's draw this code out. And this is what's going to annoy me now because I want this to go. I can do that. Okay. Let's draw exactly what happens in this piece of code. Okay, there we go. Okay, so let's go through it line by line. Okay, so the first line, line 47, is we are mallocing some space and we're creating something called new node. So now I just need to know where I am. That's not where I am. That's definitely not what I wanted to do either. Okay, so line 47, we create our node. Okay, and it's going to be called new node and it's of type struct node. So it's of type struct node and it's called new node. And let's say it's sitting at address that, and oh, I can't see what I've done here. Okay, so we've created the new node, and now inside new node is the address sitting of wherever this was created in the heap. Okay, and what I've created is something that has a data, and this is an int, and inside it also has the address, so it's got a pointer to the next item. Then on line 49, what I've done is I've said, okay, now go inside this new node, dereference it, and go into the data member of it and assign whatever data was given to this function. So it's going to have data, and then go do the same thing and assign the address of the next thing. So we'll go in here. So if you call this function, so if you call this create node function, and you give it an int data, so let's say we give it 3, and we'll give it the address of the node, and let's just say null because I don't have any other nodes for now. So let's say I've given it 3 and null. What it will do is it will assign 3 in here and null in here. And then what it will return is it will return the address of the new node back to my function so that I know where it is I can plug it in. Okay, Paula, I've also forgotten to tell you. What you also do is you run a poll, and now is a good time if you can run a poll of how we're feeling about creating a node.
Okay, is there a certain poll software that I should use?
In YouTube, you can do a YouTube poll.
Right, okay.
Yeah. And then if everyone in here can also participate in the poll so that I know, because otherwise just silence. You're polling, how do you feel about creating a node? Not reading my mind. It's before 8 p.m., Ben. Come on.
I come in between 11 and probably 10.
That ability has to stop at 8 p.m. only. We could do hands. How are we feeling here? Do we feel positive about creating nodes? Hands up if we feel positive about it. We do not care about creating nodes. We just want this whole term to just finish already and for Christmas to start. And the big holidays. I think that's really the vast vibe. Okay, but you'll just have to create some nodes before the big holidays can start. And then also sit an exam, maybe a whole bunch of exams, which is not a nice way to go into the end of the year. Okay, so we've created a node because we're pretty amazing. And just, that's it. You're done, just hats off, amazing stuff. Okay, I'm going to get rid of this because we've now done it somewhere else. And what we're going to do is we're going to call our function instead. Okay, does that sound good? So we've got a create node function. And let's say I'm going to give it 3 and null because why not? What is missing in here? If I create this node and I give it 3 and null, what am I missing right now from this piece of code? Have I tracked what this node is, where it is? Have I tracked it, or have I just lost the return address of it? Yeah, I haven't assigned it to anything, so I've lost the address. It's just going to create the node, and it's really going to go nowhere. So I really want to be able to, put the node in somewhere. So let's say for the sake of what we're doing now, we're going to keep inserting at the head because we haven't learned how to go through the list yet. So I'm going to say head is equal to, and then I'm going to create the node and put it into the head. So what that means is that the address, the pointer head, so which stores an address, is now going to hold the address of this new node that I've done. So what that looks like is I've created the node. I've said here head is equal to, and that means that the head now has the address of this new node. So it has the address of wherever this node is sitting. And then so now I've got a head of a list and just one item in the list. So how about now we do some magic and create another node? And that's pretty easy to do now because we already have a function to do it. So let's create another node. And this node, what are we going to, I don't know, choose any value. I can't, numbers, not a strong point sometimes. Let's just do 4. Okay, so let's do 4. And what do you reckon will be the address if I want to insert this node? So I want create this new node, and I want this new node, I just have to remember to do this. I want this new node to sit over here, and I want it to point to this node. So I wanted to have the number 4, and I also wanted to have the address of this node. So I really wanted to have this 0xFFF address. So what do you reckon I'll give as the address in my create node function if I wanted to have that? What do we think? Someone's answered it in the chat. That's right. I'm going to ask it to, I didn't even know that was possible. I'm going to give it the head because that's giving the address that I wanted to point to. Yeah, Tom always has the problem with the smiley face. Sometimes it just, his whole chat is smiley faces. Yeah, don't do the smiley face. Okay, so we give it the head, which is great. So what happens now is this one still has null, but this one now has the address of this other node. And you didn't see that because I didn't actually have the whiteboard on the thing. Okay, so let's say I want to do another node. Why not? The world is my oyster. And let's say I want to have, so now inside my head is the memory address of this because, well, no, actually there's nothing yet in there because I haven't assigned it anything yet. So I want this to be my new head because I'm inserting at the head. Remember in C, the right side, and what on earth was happening here? My goodness. Remember in C, the right side is done first, which means it will go in here and do this first, and then it will assign it to the left. So it will create the node. And once it creates the node, what it will do is it will actually create this structure. It will assign 4 and the address. And then I want to assign whatever is returned from here. So the address of this one, F33, that's now going to be my new head. So it's going to create a new head. So now the way I'm going to work is the head is going to show me the first node. And then the first node is going to point to the second node. The second node is going to go to null. Okay, so if I create another node also at the head, because that's all we've learned so far, I'll call my function again, and let's say I'll do 5. And again, I'll want it to point to the head because I wanted to have the address that's currently in here. So what it will do then is it will do, I'll call create node. It'll create a node for me. Let's call this one 000, and what it will do is I'll assign the data 5, and then the address I want is the head. So inside the head is 0xF33, which means it'll point this way. And now I want my new head to be this item, which means it will be 0x000. So I'll want to reassign that. So that's my reassignment here. So what we've done now is we've created 3 nodes, so a linked list of 3 nodes, which kind of looks like what I've drawn here. And I did promise to use boxes, and instead I drew them instead. I'm sorry. I will start using normal size boxes. Okay, so now we have this kind of linked list structure. That's great. How do we check, though, that it's done what we want it to do? we might need to print stuff out because that's always a good way to check. So how do we reckon we could print something out? What do we reckon? How can we traverse this list to print something out? So how do we know where we start and how do we know where we end? What do we think we would need to give this? If I want to print the list, let's create a function for it. What do you think will be the output if I'm printing something out? Everyone loves this one. There's nothing there. I don't return anything, do I? It's the magical function. It's just void because I don't need to. I'm printing it out. But what will be the input to a function that would want to print the linked list? What is the only thing I need to know to print a linked list? What do you reckon? What do you reckon I would need to know? The head. I only need to know where the first thing is, and then each node will point me to the next one, and that's how I will traverse through it. So I will only need to know the head. Very good. So the input will be the head. Okay, so I'm going to void this function because it's not going to output anything, and I'm going to call it print linked list. Oh, I don't know. Right, let's go the full hog. Print linked list, and I want to give it a struct node head. Okay, excellent. Okay, this is where it gets really, really fun. Super duper fun. Okay, I want to be able to move through this list. So what I'm going to do is I'm going to see if we can predict what we can do. I'm going to redraw this neater because currently it is not neat. And I'm going to use boxes. Okay, so we've created this linked list, a very small one. Okay, so we've, okay, so let's run through the code. Should we run through the code so that you can see what happens? Let's run through the code and we'll draw it out, exactly what we're doing each time. Okay, so we've got a struct node head. I've created a variable called struct node head. You know what I'm going to do so that that doesn't disappear? I'm just going to do that. That's a lot faster because we don't need to compile yet. Okay, line 26, we're creating a struct node head. I'm creating a pointer that's going to hold the address of the head, and it's going to be a struct node. Somehow I've also created two purple things because I've got such large hands. So first thing I have is something called the head. Then I've said head is equal to create node 3 and null. So I'll go down to my create node function, and I'm in here, and now I'm going to create a new node. So let's say this is my new node here. I don't want that to be my new node. That's going to stuff me up in my drawing. I'm going to say this is my new node, and it's going to create the structure for it. So it's a new node. It's of type struct node. Is that the little sections? Maybe it is better if I just draw it by hand. You guys read my writing when I draw the boxes? Yeah, it's all right. I think it's better than having this. Maybe. There we go. Okay. So I've created a struct node. It's called new. The address of it is at new node. Let's say, for example, it's at FFF. I don't know why I always use that as the address. And I wanted to put inside it a null. Great. So I'm going to put the data is going to be 3. That's on line 42. And then the address is null. So it goes to nowhere. Okay, that's my new node. And then I've said make that the head. So that means my head is now 0xFFF because that's what's returning out of this function. So I've returned new node and that's what's getting assigned up here into the head. Great. Then we move to line 29. I've now called the function create head with for and head. So I've said create node and I've given it for and the head. So that means I've given it this address here, so 0xFFF. Okay, so I'll go to my function of create node and I'll create another new node here or anywhere. This is going to be my new node. Let's say the address is whatever, and I'm going to assign it the data that it was given. So the data was 4, which means that the 4 will go in here, and then I will assign it the address of the next thing, which was the head, which was 0xFFF, which means that this node will now know where the location of the next one is. So it will point me to that node, to the last node. Excellent. And what I will do then is I'll return the new node. And this is now my new node, 0x000. So that means my head is now 0x000 because that's what I'm assigning on line 29. So then I'll move to line 30 and I'll create another node. Okay, great. I'll create a node with 5 and I'll give it the address of head. So now I want to have 5 in here and the address of the head, which I've been given here. So again, I'll struct node, I'll create a new node somewhere else in memory. And let's say it's sitting at this address and I'll assign the value 5 to it on line 42. And on line 43, I'm going to give it the address of head, so 0x000. So now it's going to point to this node. So what I've created is a linked list. And then on line 30, I'll assign the address of this node to be the new head. So now my head is located at 0x333. So now I know if I'm going to print something, I'm going to give it the head. So I'll give it the address of this first pointer. And that means I'll know where to start my movement through the whole thing. Okay, so what do we reckon we would need to do to actually print something out? So I've given it the head. It knows where to start. That means we need to move from one node to the next, and each time we get to a node, we need to print out what is located inside the data. Yeah, because that's the value that we're storing in this linked list. Okay. Excellent. So one way that we pulse through a linked list usually is we keep track of where we are. So I guess in a print one, you don't really need to have another pointer, but I'm going to do it just for consistency's sake. So what I'm going to do is I'm going to create this variable, and it's what's going to keep track of where I am currently located. And I'm going to assign it the value of the head. So what that means is I've said whatever is sitting at the head, whatever this head is that I've given it, that's now my current pointer. So that means that I'm now sitting over here on this node. Okay, that is great. Now, if I need to move through iteratively through I need to move through repetitively through a list, this is where a loop will come in handy. And this is where we do a while loop. Now, what do we think will be the condition inside our while loop? How long will I keep going through this magical linked list? Where do you think I will stop? Yeah, until the address is null, because null is what tells me I'm at the end of the list here. So I'm going to keep going until my current pointer is null. So whilst that current pointer, Struggletown, is not null, okay, and what this means is that when I come out of this while loop, current pointer is going to be equal to null. Because whilst it's not equal to null, I'll be doing some printing. So that means when I leave this loop, the condition will no longer be true, and that means it's going to be equal to null. And that will have some implications for other functions that we do. It's really important to understand whether you finished right at the end. So I finished Oh, you can't see what I've drawn. No wonder. That's getting quite. There we go. That's not. So it's important to know whether you finished here or whether you finish on the last node standing on it. And we will talk about the different times that that's important. So whilst the current is not equal to null, I'm going to actually do some printing. So I'm going to print out, third time lucky. Yep, I'm going to print out the value that is stored inside the linked list. And then I'm going to, and then how do I access it? So I'm moving through by moving the current to the different nodes. So it's going to be through the current. And because it's a struct node pointer, I'm going to use the arrow to access a member of it. And then which member am I accessing? Is it data or is it next? Which one is going to hold the value? Yep, data, excellent. So I'm going to print out whatever is sitting inside that data. And then I need to really move it along. I need to move to the next node. How do you think I can move to the next node? I need to really move this current that I have, this bit here, over to my next node because I'm done with this node. I've printed out its value. I want to move along now. Yeah, that's right. So if I go current and I access the next thing, I'm gonna know the address of the next thing. So what I'm saying is that my current, so the address of my current is going to be what is sitting inside current next. Well done. Because inside current next is my next address. So I'm saying, okay, now my current is going to be equal to whatever is sitting inside here. So that will move me along to this node over here. So it will move me onto the next current. Okay, and then when I come out, I've got a null. So we can even simulate that. We can just say here printf, and I'll just print out a null just so that you can see that the list is finished. Okay, so let's save it and let's run it. Let's see what happens. Forgotten to prototype. And my print. All right, let's try this again. Okay, that's better. And let's run it. And I've forgotten to call the print function in my main. So it's going to print nothing because I forgot to actually call it here. Okay, so let me call it. So the function is called print linked list, and I'm going to give it the head pointer, which is storing the address of the first node. Okay, let's try that again. Compile and run it. And it's going to print out 543, and then it's going to finish with the null. And it's doing that. So remember, it's got the 3, the 4, the 5. So it's exactly how we've got it on our list, 543, and then it goes to null. So it's finished. So what you've done is you've created basically a little linked list structure. Okay, now, okay. Oh, quite a few people are terrified. Well, that's okay. We'll go through it again. I think now is a good time for a little break, and then we can come back and then we'll go through it again, and maybe we'll go through the code again with pictures and stuff. Yeah, let's have a little break. Then I've got to do that, don't I? Okay, can the people online hear me? Yes, no, maybe. Thank you, Ben. I wish you'd stop playing. You know, it's really weird hearing your voice back.
I'll try and do it quietly.
Yeah, and it's apparently because of the way, well, sorry, no, I watched a very prolonged documentary about why that is, but no one needs to know. Okay, here we go. All right, should we run through the code? How's everyone feeling? Should we run through the code and draw it up again? Or is everyone feeling good with that? Or would everyone like to do the printing, run through that code and draw it up? Yes, no, maybe? No, maybe? There we go, printing then draw. Thank you for the audience on the online words. Good, put them together today, very. Okay, let's print it out. All right, so we've called this function print list, and let me just prepare this. I don't have a Kahoot today. It was all too much for me last night. There will be one on Monday. Okay, here we go. Print list. So let me just do this. My pen stopped working. Here we go, it's back. I'll get rid of these so that I can. Okay. All right, so I have this lovely, lovely linked list, and I've just called my print function, and what I did is I gave it the head. Inside the head is currently the address 0x333, so I've given it that address. Okay, so the next line, line 65, I've got struct node current is equal to head. So what I've done is I've created another pointer here called current. So it stores an address, and the address that I've put into it is the address of the head that I gave the print list. So that means it's going to be 0x333 is the address that is currently inside current. Great. Now my condition inside this while loop is now whilst current is not equal to null. So whilst this address is not equal to null, I'm going to keep going and doing something. Okay, now if my current is sitting at this address, what that means is current is this node over here. So it's that first node that has the address. That's the wrong address. No, it's not. That's the right address. Okay, good. So my current is sitting up there, and I'm ready to start my loop. So I'll check, is the current not equals to null? Yeah, it's got a node, it's got an address, it's not equal to null. So I'm going to go inside my while loop. And what I'll do is I'll print out the data. So I'm going to say, okay, print out an int. So print out whatever's sitting inside my current data. So that means dereference the address of current. So that means I'm inside this node and access the data member. So print out the 5. Done. Then it's saying current is equal to current next. And you are going to get very sick of writing that. You're going to be writing that a lot, especially in assignment 2. So what that means is we'll do the left side first. We'll find out what is sitting inside here, inside current next. So dereference the current and see what is sitting inside next. Inside next is 0x00, and then assign it to current. So my current is now going to be equal to 0x000, which means that my current has now moved to the next node. And it's now sitting on this one. I'll go back and I'll check my expression inside the while loop. So is my current not equal to null? Yep, it's not equal to null. It's got an address that's not null. Excellent. So I'm going to go inside the while loop and I'm going to print out whatever is sitting inside current data. Inside current data is a 4, so I'll print that out. And then what I'll do is I'll grab the address that's sitting inside current next, and the address is 0xFFF, and then I will assign it to my current variable. So I'm going to assign it in here, so it's going to be 0xFFF. And that means that my current is now sitting over here on the third node. Excellent. So then I'll check again. I'll check the condition of the while loop. Is my current not equal to null? Yes, it's not equal to null. It's got an address. So that means I'm going to go inside the while loop. I'm going to print out whatever is sitting inside current data. So I'm going to go inside current data and print that out. And then I'm going to grab what's sitting inside my current next. So I'm going to grab this null and I'm going to assign it to my current. So that means my current is now going to be equal to null. And that means my current is now over here where it's equal to null. It's equal to nothing. Okay, great. I'll go back into my while loop and I'll check the condition again. So is current not equal to null? Well, it is actually equal to null now, which means that I exit out of this while loop. I don't go through it again because the condition is no longer true. So that means over here, my current is equal to null. And then I'm just going to finish by printing null, and then I exit out of this function. And that is the printing. Paula, could you please do a little poll? How are we all feeling about the printing? Okay, someone's got a question on there that says, can the statement for the while loop be current next is not equal to null? That's a really nice question. So what you're asking is that current next cannot equal to null. So what it means is that you're always checking this address. So is current next is not equal to null? Is current next in here not equal to null? Yep. So let's see what will happen if you do it like that instead of doing the current is not equal to null, because I think this is a really nice question because it creates a whole bunch of things. So what happens if it's like this? Okay, and we are going to use it a few times like this. So let me erase all of this and we'll run through it with this condition now. Okay, so again, we've passed the head pointer to our print function. And let's get going. Okay, so we've got our current head. So the current is sitting at 0x333. Excellent. And now we're going to say, is current next equal to null? So what I'm doing, I'm not checking this one. What I'm checking is I'm checking what's inside. So my current is over here. And I'm checking what's inside current next. So I'm going to check, is this over here equal to null? No, it's not. So I'm going to go inside this while loop and I'm going to print out my data. So I'm going to print out the 5. And then I'm going to move along to this one over here. Okay, so my current is going to become whatever's sitting inside current next. So it's going to become 0x000. Excellent. Okay, I'll go back and I'll check my condition again. Is current next not equal to null? So is this equal to null? No, it's not. Okay, fantastic. So I'll keep going. So I'll go back in here and I'll print out my current data. So I'll print out the 4 and then I'll move my current along. So I want my current to be equal to current next, which is 0xFFF. So that means my current is now over here. I'll check the condition again. Is current next not equal to null? Well, actually it is equal to null now, which means that I will skip this while loop and I'll go back to printing just the null. So what it will mean if you use current next is that you're going to skip this last node and you're not going to print it out. Now, sometimes this will be useful, and we'll talk about that case next, actually. But in our current situation, when we want to visit every single node, we want to go until the very end of the list. So until the current is not equal to null, because we want to stand at every single node and actually access what's in every single node. Otherwise, you're not going to be accessing what's in that last node. Okay, I hope that answered that question. Okay. Very good. Okay, so let's do how we actually, let me look at this. Okay, well, the still terrified percentage has gone down by half, so that's good. Look, it takes a little bit of time to get linked lists. This is the first time you've seen them. Maybe this is not the first time you've seen them, but this is the first time you're playing around with them. Don't be so hard on yourselves. It takes a little bit of time. I wouldn't expect you all to leave here and be like, I'm a linked list expert. I can now do everything in a linked list. They are hard, and the best thing that you can do for linked lists is always to draw it up, because then you can pick up mistakes much faster, and you can also see what you actually need to do. The code almost writes itself, dare I say that, but it certainly sometimes feels like it if you draw a diagram. Okay, let's try, now that we can move through a list, we've talked about that, how about we do a function that inserts a node at the end of the list? How do we feel about that? What do we feel about that? Well, Ben is keen. I guess if you're keen, Ben, we'll just do it.
That's a great idea.
Yeah. Okay, and then, you know, we can come up with other things as well if we want to. All right. What would we need to do? What do you think if we were adding at the end of the list? What will be the output? If I was inserting at the end of the list, what do you think will be the output of that? Or, you know what, let's go. What do you think will be an input of it? If I was inserting a node at the end of the list, what do you think I would need to give this function to insert a node at the end of the list? What do we reckon? Anyone? What do we reckon? What if I want to insert at the end? What do I need to give it? How will I know where to insert? How do I know where this linked list is? It's just floating around in memory somewhere. I would need to know where I should start. Yeah, that's right. So all you ever know of a linked list, and this is going to be like a common theme, the head of the list. Because if you know the head, you can get to every other element of the list. So if I want to get to the end of the list, I need to know where it starts, because in a linked list, you have to travel and sit at every node. So I'm going to give it the head of the list so that I know how I can get to the end. And then what do you reckon I will return? You don't necessarily really even have to. But anyway, we will return something for just, why not, good practice. What do you reckon we'll need to return? What is the one thing I always want to know about a list? What do I really always want to know? Because otherwise I will never be able to access it again. Of what? Address of? Yes, the address of the head, because if I don't know the address of the head, I can't do anything. So very good. A few people are saying address in the chat as well. Okay, so we're going to be returning the head, really, but it's going to be a struct node address, and I guess the input is also going to be a struct node address. Okay, so let's do insert it there. So struct node, and we'll run through the code again. Strut. My node is having it's strutting. Okay, insert at, and you know what it's, if you the end of a linked list is called a tail. So we could say insert at tail, or maybe I'll just say at end so that it's not as intense. Okay, and I'm going to give it a struct node head. And there is that space that I always forget to do. Get to experience it firsthand. Okay, so we are now at a similar problem. We would like to insert, I don't want to insert at the head now, I want to insert at the tail. So I'm currently sitting at the first node, but I really want to get to the end. So what do we reckon we need to do? Just like without the code, what do we need to do you think, to insert at the end of a list? Yeah. Perfect. So we want a while loop that will get us to the end of the linked list. And then when we get to the end of the linked list, we're going to insert. Okay. Oh, amazing. In the chat too. Oh, for those playing at home, amazing. Okay, so once again, and you're going to get real good at this, I'm going to have a current node that I'm going to play around with, okay? And I'm going to set it to the head, okay? So that means my current is what's holding the address of the head to start with, and then the current will move along through the list as I go through it. Okay, so now we're going to have a while condition, and this is where you need to draw things up so that you know where you need to finish. So will I go to the end of the list? So the way we did when we were printing. So when we were printing, the current finished over here. Will I go here to insert? Or do I need to stop at the last node? What do you think? If I'm over here at null, I no longer know where I was previously. I'm not that clever. So what do you reckon? What do you think? Just take a wild guess. Exactly. We want to stop at this one over here, because if we go all the way to the end, we're going to lose the last node and we won't be able to link up. We won't be able to actually insert something and point it to the next node. All right, so that very good. We want to go until current next is not equal to null. So this is the case where we're going to be stopping at the last node. So whilst current next is not equal to null. I don't like this keyboard either. I wish they would just, I'll have to move that into my big bag of tricks. Okay, that means that when you exit out of this loop, your current next is equal to null, and you are standing, sitting, I don't know, crouching at the last node of the list. Okay, so what do I want to be doing inside the while loop? You've already said I want to just keep moving along, and to move along I do current is equal to current next, which is what moves my current pointer over by 1. So it moves it to the next address and to the next address. So that means that when I come out of this while loop, I'm going to be sitting at the very last node. I'm going to be sitting at this circled node. Okay, excellent. So now I'm sitting at the end. Then what that means is I can now make a new node. So what I will do is I will create this node. Okay, I need something to store the address of this new node in. So I'm going to create a pointer to a node. So I'm going to create a place to store the address of this new node that I create. And then lo and behold, I've got a function for this. I'm just going to call my create node function. So I'll create node and I will give it 13 and I'll give it a null because it's going to go right at the end. So I wanted to point to null because it's going to be I'm inserting at the very end. So I need it to be at null. Okay, now that I've created this new node, so what I've done is I have created a node. I've used that function to create a node. It's got the number 13. It's got a null here. But right now, and it's at the address new node. Right now, it's not connected to anything. It's just floating around in memory. It's there, but it's not connected to my linked list. So what I need to do now is I somehow need to connect my last node. I need to connect this address to the new node that I've created. So how do we reckon we can do that? So we'll access this address of our current node, and what will we point it to? And so that address is sitting inside current next, and what do you think we can point it to? Spelling is just not a strong point. So what do you reckon it will point to? If I want this address now to not be null, I want it to be the address of this new node that I've created. Where is the address of that new node that I've created? Where do we reckon it's stored? Oh, someone's got it in the chat. What about in the live audience? I'm going to start asking Ben questions soon. On the spot. So where's the address stored? What do we reckon? Exactly. So we want it to be our current next, we want that to be the new node. So wherever this new node is, this is no longer null. This is now going to be pointing to the new node. And now I have this linked into my list, okay, which is very, very nice. So I've got my new node now, and now I just need to return something. What should I return? What did I say I'd return? How will I know where to, in case this list has changed somehow? Yeah, the head, exactly. That's the only thing I ever need to know, really, to get through my linked list. Okay, and we've got something that we'll insert at the end, maybe. So how about we use this function and then we print it and see if it works. So let's copy this. And then we'll run through it with some drawing. Okay, so we've got that. And now I need to call in the main. That would be really useful. Okay, so I've printed that out. And now what I'll do is I'll call set at the end. I forgot what I've called the function. And I'll give it the value. Oh, I've already given it a value here. I've annoyed myself. I've said that I'm going to give it the head, so I'll just go, okay, we can change this function to then be where I can give it something from here. Okay, insert at the end, at the head, and then I'm going to print it out again. Okay, let's try that. Oh my gosh, my spelling. Thing. Current. I got a little bit too excited. Let's have a look. Where have I spelled current with 3 R's? Just here. Anywhere else? 2 R's. 2 R's. 2 R's. Amazing. Okay, so let's see what it does for us. Oh, it does nothing because I also changed. Oh. Okay, I never returned this to normal. Let's return this to normal when I explained why that won't work. Let's save that. Let's see what that does. So let's clear that, and let's now compile it again. We'll run it again. Okay, so now it's doing the first list, which is 5, 4, 3, and then null. And then the second time I print it, it's now got the inserting at the end of the list. So 13 is now coming before it, and then null. So let's run through it with the code and the drawing now. Please hold back your enthusiasm. Thank you. Ben, you have to come to every lecture now.
I'll do that.
Okay, let's do... I've kind of done a little bit, but I'll just do it again so that you can see. Okay, so this is my list right now. And I'm heading out to null. Okay, and I want to now make this magic happen. Insert at the end. Okay, line 63, struct node current is equal to head. Great, I've got a current and I'm assigning the address of the head to it. I've assigned that. So that means my current is now sitting over here. Excellent. Next, whilst current next is not equal to null, I'm going to move it along. So let's check the condition. So line 65, whilst current next, which is the address sitting in here, is not equal to null, that is true. So I'm going to go inside the while loop and I'm going to say current is equal to current next. So I'm going to take whatever's the address inside here and I'm going to assign it to my current. Excellent. And that means that my current is now sitting over here. Great. I'm going to check the condition again. Whilst current next is not equal to null. So is this current next equal to null? No, it's not. Fantastic. I'm going to go inside this while loop and I'm going to say current is equal to current next. I'm going to take this current next and assign it to my current. Okay, great. I'm going to go back and check the condition again. And that means my current is over here. So I'm going to check the condition again. Is current next not equal to null? Well, it is equal to null, which means I'll come out now of this while loop. So now I'm on line 70. So now I've got struct new node. So I'm creating a new node. And I'm using my function create node. Okay, so I'm sending it with 13 null and it's over here. So I'm creating a new node. So what I'm doing is I'm drawing a new node. Let's say the address of it is that. Okay, and it's got some data here and then it's got an address and I've sent it with 13, which means that on line 50, I assign it the data 13. And then on line 51, I assign it the address that I gave, which is null. And what I'm doing is I'm returning to my function the address of this new node. So I'm returning this 0x222. That's going back. By the way, the addresses are completely made up. They're just rubbish that I've just made up. So these are not actual addresses, but it just helps to understand what's going on. So then I return back to here, and that means inside this pointer new node that I've created is assigned what I've just returned from that function, which is the address of the new node that I've just created. And then what I do is I go inside current next. So my current next is, this is the current, so the next is the address here, and I assign it the address that's inside new node. So I give it 0x222, which means that it now doesn't point to null. It now points to this node here, and this is the node that goes to null. And that's how I insert at the end. I feel like there has to be like and that's how it happens. So that is how that happens, which is amazing. How are we feeling about that? Paul, please. Thank you. How is everyone feeling about that? Is it starting to become a little bit more happening? Yeah, a little bit more happening. Maybe you can do other things too.
With the current like dereferencing from next, so what's happening in line 71?
Line 71, yeah. Okay, so in line 71, what I have is I have a new node, and inside new node, I have the address of what I've created, and then I assign it to current next. So current is this node over here. I'll swap colors. Current is over here. So I dereference current and go inside the next member, and that means instead of null, I'm assigning it that address that is inside new node. So that's what's happening on line 22. So what I'm doing is I'm changing it from pointing to null to pointing to this new node so that it's inserted at the end of the linked list. And so this is why it's helpful really to draw, because then you'll start inserting in the middle of lists. And what that means is you'll need to change what's happening over here where it's pointing to and what's happening over there where it's pointing to. So it's really helpful to draw it out because you can tell then which current you have to point to and who is next and who's new node and where you are going with this. Is the poll running? Sorry, I didn't see. Well, Terrified has increased. Oh, Terrified has really increased. Ah! Yeah, so when we're returning the head, all we're doing is we're returning the address of the first node so that you can pulse through the linked list again. And the reason for that is, I can simulate the reason for you. I'm just thinking if I should simulate it now or if I should just tell you the reason instead of just going off gangbusters. What happens if I have, and I'm going to run into an issue here as well because I've also done something in main that will prevent this from happening nicely. So how about I put it out to the audience? When do you think this might be an issue? When do you think? So right now, you know, who cares? The head hasn't changed. It's still the same. Nothing's. When will this be an issue? When might the head change? If I'm inserting at the end. When might the head change? There's like 3 or 4 conditions that you always have to think about of a linked list. And one of them is, what if there's nothing there to start with? So it's at null. And so then when I insert at the end, I'm actually going to modify it by having this head. But I'm also going to run into a whole bunch of other issues here because I should be checking whether it's an empty list. And we will do that. But I think maybe I should keep an eye on the time and not start doing it now into like these are the 4 conditions you should always consider. That will be the Monday where we will be considering there's 4 conditions you should always kind of think about. And that's when we'll also insert into the middle. Maybe we'll delete, who knows, the world is our oyster. How is it going over here? 34 votes only. It's not many votes, but 44% of 34 votes are terrified. Feels very strong. When's assignment 2 coming out? I was trying to give you a little rest. So I'm thinking tomorrow. I hope you enjoyed your 2 days rest. I'm sorry, the terms are just horrible. It's always whether to give you more time or whether to give you a rest. Yeah, so assignment 2 will come out tomorrow. Assignment 2 will be all about linked lists. Don't stress about it. I just want you to read it. And then on Friday, we're going to run a live stream for it. So you can, you know, familiarize yourself a little bit more with the spec. And then on Monday, we're going to do some more like sort of solid things. And then I've actually got a lecture program thing happening as well. So what we did with 2D arrays, I'm going to do a bigger linked list program that's going to be similar to some of the first stages of the assignment to help you get started in them as well. Yeah, the address hopping is confusing. It's yeah, this is where you just have to. Yep, I can't deny it. It is confusing. It can be very confusing because you know which variable holds an address and which one doesn't. The pointer holds the address, and that's why no one likes pointers. But they are pretty amazing, actually. Yet you will think that. Yeah, so returning the head is kind of like good standard practice for when you modify things. We will see, I will do examples where we will change things that will impact our head. Okay, should we just do a little function just so that we can get some more practice with these? I won't insert any more. I think I've broken your spirits a little bit this morning. But let's do like a really simple little function, maybe one that does the size of a linked list, just for funsies. Okay, let's do one that does the size of a linked list. Okay, what do we reckon will be the input and what do we reckon will be the output? I didn't mean to shout input here. Okay, if I want to know the size of a linked list, what do you reckon I need to do to find out the size? Linked list is very, you always do the same thing to it. You move through it. So to find the size, I only know the head. I will have to pulse through it and count things up as I go. Yeah? So what do you reckon the input will be to this function? Always the same thing, almost. Yeah, the head, exactly. It's like, yeah. So that's my struct node. So it's going to be the head. Excellent. And what do you reckon will be the output if I want to know just the size of a linked list? Just an int size, whatever it is. Excellent. So let's int size list, and we're going to give it a struct node head, and we're going to do that. Excellent. And you know what? Before I forget, I'm going to put that as a prototype. And here, I'm even going to call it amazing. If I remember what I've called it, size. Okay, right now it's going to be lost if I call it like that, whatever it returns. And I really don't want another variable, so I'm going to do it like this, which is not the neatest way to do it. So tell me if this doesn't make sense. So I'm just calling the function inside here because it will return an int for me. Okay, and let's save that. And let's go down and let's actually write the function. Okay, so what do we think we need to do in the function? It's really all the same things that we always do. We need somehow to keep track of what the size is. So I'm going to have an int counter. And then I need to count up my nodes. Okay, so I'm going to need to have some sort of while condition that will count my nodes up. And what do you reckon where will I need to stop? What should my expression be? Should I stop at the last node? Should I go past it and stop at the null? What do we reckon we're going to need to do? What do we reckon? Stop at the last node, go to null. Okay, there's in the chat there is two options. Okay, hands up, stop at the last node. Okay, no hands. Hands up, stop at null. Oh, lots of hands. Oh, Ben, thank you for participating. Yeah, okay. So let's go all the way to the null because we need to count the last node as well, right? So let's stop at the null. So that means we're going to current is not equal to null. Okay, that means that when we exit out of here, my current is equal to null, and we have gone through all the nodes. Okay, great. So I want to count up my node. Yeah, so that means I want to increase my counter. Probably here would have been helpful to initialize it to something. Okay, so I want to increase it by 1. I could have just done ++. And then what do I want to do? What do we reckon? What do I want to do after I've counted something on? How will I move along myself? How will I hop to the next node? I've got a current, but I haven't actually, no one's even pointed it out. I've got a current with nothing, actually, there's nothing happening. I haven't actually. So we want struct node current is equal to head. Now that makes more sense. So how will I move this current along? Right now it's at the first node. I want to move it to the next node, and then to the next node, and then to the next node. Come on, come on. I know you know it. Maybe. There's a few in the chat. Yes, current next. Okay, good. This is going to be your nightmares. Current next. Okay, what do we reckon? Do we reckon that's going to do it? Oh, we need to return something potentially, don't we? Okay, how does that look? What do we think? Looks okay? Maybe, who knows? Let's try it. File, it compiles. Let's run it. Ah, the linked list is 4 items. How nice, which is 4 items. So that's quite nice. Shall we go through it with a drawing to see how it works? How do we feel? Drawing, no drawing? Or is everyone comfortable with the size? Drawing. No drawing? Drawing. Yeah, let's draw. Let's do the drawing. Even though this drawing is getting to be a bit messy, I'll try and tidy it up. Oh God. Should I just start again? Yeah. That was so polite. That's what my brain looks like. I was worried that on Monday people would see what my desktop looks like. A bit like that, really. Okay. Starting afresh, beautiful. I'm going to switch to green. No, green is not as good. I'll go black and white. Okay. So we've got our list. And now I've forgotten what it is. Let me just look here what our list is. 5, 4, 3. So 5, 4, 3, 13. Okay, so let's pretend these are the addresses. Okay, so that means that this one is pointing to 0x111. This one is pointing to 0x222, so it's going to point to this one. This one is 0x333. This is the last node, so it's going to go to null. Okay, and then I'm going to have my head, and the head has the address of the first thing, so 0xFFF. Okay, so let's have a look. So I've passed it size linked list, and I've passed it the struct node head. So I've passed it the address of the head. So I've passed it this address over here. Okay, then I've gotten a counter, and I've made that counter equal to 0. And then I've created another pointer to a struct, and that pointer is called current. And inside it, I'm holding the address of the head. So I've assigned it the address of the head. Great. Now I've got my current. That means that my current is over here. Okay, so the current is sitting over here. So now it's time to get into it. So I get to line 103 and I check the condition. Whilst current is not equal to null. Is the address of current, so this address here, equal to null? No, it's not. Fantastic. So I'll go inside this loop. I'm going to say counter is equal to counter plus 1. So I'm going to increase that by 1. And then I'm going to say current is equal to current next. So on the left-hand side, on the right-hand side, left and right also not strong points, I've got current next. So that means I'm accessing this member over here, and I'm assigning it to my current. So my current is now going to be 0x111. Okay, and that means the current is now sitting on my next node. So I'll go and check the condition again. Whilst current is not equal to null. So is this address equal to null? No, it's not. So this condition still holds. So I'll go inside the while loop. I'll go counter is equal to counter plus 1. Fantastic. And then I'm going to move the current along. So I'm going to do current next. So I'm going to grab this address over here, and then I'm going to assign it to current. So I'm going to move this and assign this address to current. So 0222. And that means my current has now moved to the next node. It's now sitting over here. Okay, great. And I'm going to go back and I'm going to check the condition again. So whilst current is not equal to null. So is current not equal to null? Yep, so the condition is still true. I'm going to go inside the while loop. I'm going to increase the counter by 1. And then I'm going to do this again. So I'm going to do current next. So I'm going to grab my current next and assign it to current. So I'll assign it to my current. And that means that my current has also moved to over here now. Fantastic. I'm going to check the condition again. Is current not equal to null? Yeah, so it still holds true. So I'm going to go inside the while loop. counter is going to increase by 1, and then my current next. So I'm going to grab my current next. So grabbing my current next and then assigning it to current. So that's now going to be my null. Okay, then I'm going to check, is the current not equal to null? It is equal to null, which means I no longer go into this while loop. I come out of it, and that means outside of it, this is my current is now equal to null. And I'm going to return the counter. So I'm going to return the last value of the counter because that's what was doing the size of the whole event. How's that? Paul?
Yeah.
Quick poll. Yeah, someone's saying this picture is so messed up. I should show you my desktop.
I think that was the other one.
Yeah, that was the other one. Yeah, not this one. This one, look at how neat and tidy. No, I've already ruined it. It started out a bit more neat and tidy. How is everyone feeling about this diagram?
Are those the actual addresses or are they just
They are things that I made up to make it easier. The actual address is more digits and it's a hexadecimal, which is why I always use 0x, but then I've shortened it to 3 numbers so as not to pollute my diagram even further. But it's basically, they're random, right? Malloc will grab some memory wherever and he'll assign an address, which is why they're not in order. They're just sitting randomly somewhere in the heap. They're completely, and that's why you always need to hold the address because otherwise you won't know where it is. You'll lose this piece of memory. All right, I think we're going to finish there. But if you do have feedback, I did create a link this time finally as well. If you have feedback, do please tell me. If it's too slow, too fast, what you would like to go over again, let me know. Because on Monday, how are we feeling about an in-person lecture or back to the green room? What are we feeling is the, oh, will I share the code later? Benjamin.
It's no, I swear.
The code is already up.
Yeah, the code.
Oh, the code is,
Come on.
I have chmodded it.
Ah. Which one are we looking at? Oh, list.c. Oh, yeah, no, it's up.
It's
up.
chmodded, it's chmodded.
Yeah, that's fine.
Yeah.
better than
How is everyone in person or in person? In person is still working for everyone. So, you know, next Monday's Halloween. So I love Halloween. Excuse me in advance. I might be dressed up. If anyone else feels like, that's fine. Okay?
I'm dressing up my online.
Yeah. I've got a series of costumes to choose from. Thank you all for coming in person again. That was really lovely. And I'll see you on Monday.
It might be useful in case you need someone else
So I think I need to go YouTube studio.
to.